Welcome everybody to the Lab 1 pre-demonstration. As I mentioned, this first lab, there is a bunch of different steps and it's your first time executing a lab in Rogue Arena, getting used to Cobalt Strike. So this lab review will be a little bit different. I'm actually gonna go through the full lab, demonstrate everything step by step. We're gonna talk through all the knowledge base questions as I progress through, and then it'll be up to you to jump in and complete the lab on your own. This lab won't have any concluding lab overview, mostly just because I'm running through it all right now with you. So first things first, let's get set up in Rogue Arena here. I have my Kali machine already open. This is our lab right here in our Rogue Arena curriculum viewer. As you can see, I'm on Lab 01, infrastructure setup right here. Let me get that closed up. So we're gonna start at the top and kind of work our way down the bottom, answering all of these questions as we go. Now the lab says to kick off our assessment of Electro JNN, we need to set up our infrastructure. And then a little note here that I already mentioned to you all in the actual lecture. Not only are we gonna be working through the lab here, but we also may reference some of the slides as well if we need specific syntax commands. So we need to follow the directions from the lecture and set up and configure Cobalt Strike. So let's go over to our student share here. This should have all the tools we need to actually complete our lab. I'm gonna jump into the resources folder. I've seen a lot of students when they get started, they actually copy this resources folder over to the desktop. I kind of like that idea, so I'm gonna go ahead and do that. So I'm gonna copy that over to our Kali desktop. It might take a second to copy all that stuff over. And now we have all the tools we need right here. And now the moment we've all been waiting for, we wanna go ahead and extract that Cobalt Strike zip file. So we're gonna go into the resources folder here. We'll go down into infra setup, and then you'll find your Cobalt Strike.zip. Open this up and copy it out to your desktop. Perfect. So now we can go take a look at the folder we just extracted. And I want to kind of talk through a few of the different things you'll see here. As I mentioned, we have some Rogue Labs helper scripts built into our team server sh file, as well as our c2 lint file right here. Our helper scripts ensure that both of these commands are actually executed against the team server that you specify. That allows you to remote control that team server just like we've been talking about in lecture. Next up, we need to open our jQuery c2 profile in Sublime Text and review and change the following. So let me jump over to Cobalt Strike. We'll open up that C2 profile. And if you've forgotten what the C2 profile is, the C2 profile is responsible for not only configuring how Cobalt Strike actually communicates back to our team server, you can change the HTTPS URI, you can change some of the get headers, the post headers, but you can also configure the sleep time and various other post exploitation things as well. If you're working towards AV EDR evasion, you'll definitely be building your very own C2 profile and Arsenal kit kind of combined to really customize your Cobalt Strike beacon. So let's open up our jQuery profile. I prefer Sublime Text. You're welcome to use Visual Studio Code if you'd like as well. But I'm gonna go ahead and drag and drop that over to Sublime. Now, as I mentioned, our C2 profile is mostly plain text, but jumping back to the lab here, we need to review the 6 URIs configured. So Control F and search for primary. So I'm gonna do that, primary. And then it also says I can search for backup and that I need to make a note of the root URI for each. You should have a total of 2 unique root URIs. So according to our screenshot in the slides, we said it was slash and then whatever that name was, right? That's what we need to set up with Apache ProxyPass. Well, looking over here, we have our primary, and then here's our first root URI, energy forms. I'm gonna continue clicking find down here to find the next one. See what we got. Primary, set URI. No, I don't see primary. Let's continue on. Oh, HTTP get primary. Energy forms, there it is again, but that's okay. We just need the one. Keep clicking. Post, primary, energy forms. So it looks like we found all of our primary root URIs. They're all the same, slash energy forms. I need to go ahead and write that down. So I'm gonna open up Sublime Text. We'll say primary, redirector, root URI, energy forms. Then we have that for later. We can refer back to that. So now it says, we should go ahead and search for backup. So we'll Control F for backup. And it looks like the root URI here is power forms. I'm going to continue clicking through power forms. Power forms. Again, they're all the same. They're all under that power forms root URI. At this point, if you really want bonus points that don't matter at all, you could go ahead and change all those URIs to some other string. We talked about in the lecture how that could be a really long, hard to guess URI. So it could be a GUID, really long string, whatever you'd prefer. You could change that here and everything should work fine as long as you keep that changed on your Apache ProxyPass as well. So I'm gonna jump over here. I'm gonna make this note. Let's say backup redirector root URI power forms. Again, I have this notated for later. Awesome, so we got those done. It says locate, set sleep time, and change the default sleep to 90 seconds. Again, this is changing that default sleep when the Cobalt Strike beacon first calls back. How long do we want it to sleep before trying to contact us again? So we need to look for set sleep time. And it says 90 seconds here. So we're gonna go ahead, this is in milliseconds, which may make this a little bit more confusing for you all, but go ahead, 90,000 milliseconds is 90 seconds. Good to go there. It says locate set pipe name and set pipe name stager. So this is where we're getting into a little bit more of kind of the post-exploitation stuff and how Cobalt Strike looks when it's running on a host. Specifically for this, we're setting these pipe names, which will affect SMB beacons. So let me Control F, we'll set pipe name, set to pipe name stager. Now, looks like our C2 profile, whoever made this, Thread Express, already got us a lot closer to the finish line. This is a common Chrome named pipe. So we have Mojo here. If you've ever done C2 profile stuff with Cobalt Strike, people tend to kind of use pipe names that are common on different machines. Again, if you want some bonus points, you can actually list out pipe names on a Windows machine, take one of those pipe names and configure it here. But I do have one really important note to point out here. I want you all to look extremely closely right here. Does everyone see the 2 pound symbols right here, or the hashtags? Well, Cobalt Strike will actually randomize some numbers to go there. You never want to change those hashtags. If you remove those, Cobalt Strike will use the same pipe name across the entire board, and this can be devastating when you have multiple SMB beacons running on the same host. You have conflicts, it kind of messes everything up. So always make sure you have the 2 hashtags at the end here to ensure it works correctly. So, we want to further obfuscate. We don't want to use the exact same profile names. So I'm just going to rename, change some of these numbers, and we should be good to go. Good enough for me. Then it says save your changes and close the profile. So we're going to go ahead, we're going to go file save, and we're off to the races. Now we want to move forward and validate our profile. We talked about how there are so many variables in here that it could be easy to mess something up. Maybe you leave off a quote, you forget a semicolon at the end of the line. It's better to find those problems right now, right before we load up Cobalt Strike. So running a C2 lint is actually pretty easy and straightforward. So we're going to open up our terminal here, going to CD into our desktop, CD into our Cobalt Strike folder. And you're going to see a few of the different files here that you can call. Specifically, we want this c2lint.sh. So I'm going to run sudo c2lint. Again, our Rogue Labs helper scripts do require a sudo. We're going to give it our jQuery profile that we just updated right here, hit enter, and then we'll have to enter in the password for our Rogue Operator account. And we get this nice little message from our helper script. Please enter the team server IP address where you want to execute. Our IP address could change from lab to lab, so make sure you read that lab overview guide that gives you all the different IP addresses you need for the course. But if nothing's changed, then we want 172.31.5. It should go ahead and check the connection to that host to make sure that we can reach it, and then it's going to process the C2 profile. This may take 45 seconds, this may take 30 seconds. It kind of depends on where that automated loop is when it's checking that C2 profile. And it just came back. You can see successfully executed C2 lint, and we can scroll up and read all the different output from that C2 lint command. This will go ahead and validate that profile, make sure everything is perfect. As we mentioned during lecture, if you see some references to our spawn2 addresses being broken, that's because we hard-coded these paths in our C2 profile. We won't be using spawn in this class, so don't worry about about that. If you do see other errors about missing brackets or something not parsing right, you may have to give your C2 profile another look and make sure you didn't break anything. And that brings us to our first knowledge check question right here. What line allowed you to change the default sleep time? Why would an operator want to make this value larger? Now, the line number doesn't necessarily matter. We just want to get you in there looking at the C2 profile. You saw me edit that. But the other question's a great one. Why would you want to make that value larger? And the reason being, you don't want a beacon to call you back immediately, let's say every 10 seconds. That would be bad tradecraft. That could potentially get you caught in a customer network. Now let's really think through the ramifications of this. If your target system reboots and Cobalt Strike starts up fresh and starts calling you back, you may want that to be a 4 to 5 minute sleep initially. So it's just beaconing back every 5 minutes, very, very chill. And then when you actually want to interact with it, you could sleep it down to 45 seconds, 60 seconds, whatever you're using for your operation. Question 2 here, what is the root URI for the backup redirector? And for the primary, you will need these values later in the redirector configuration. Well, we already know that. We already took those notes, power forms and energy forms. Again, that could be anything you want to set for your operation. You could change those if you want. You just have to be consistent and change it everywhere in the profile it is. You'll also see in other more advanced profiles, every URI may be different. There's a ton of different options. We did simplify things a little bit for all of you in the class. Question 3, what is the purpose of the pipe name variable? As I said, these strongly correlate to the SMB beacons we'll be using later on in the class, and we'll cover that a little bit more later, but I can give you a quick explanation now. Named pipes are somewhat similar, or I like to think of them, somewhat similar to network ports. As you all know, a computer can listen on several network ports. Maybe it's listening on port 22 for incoming SSH connections. Well, different applications running on Windows computers can listen on different named pipes. In our case, we're listening for named pipe name of MOJO, which is a common Chrome pipe. Anyway, those can listen on named pipes, and then any incoming connections to port 445 can actually connect to those named pipes. So again, we're going to talk about this later when we use SMB beacons on different Windows servers. Just know they're kind of similar to network ports in that it's a service listening for something. And in our situation, just know we commonly refer to that pipe name when we're using SMB beacons. Awesome, we crushed those questions. Moving on, we want to set up Cobalt Strike using the information presented in the slides. So we're going to go ahead and open our terminal up here, and then we're going to CD into our desktop, our Cobalt Strike folder. And if we look closely, you'll see our teamserver.sh file. Again, we have mimicked the syntax of the official Cobalt Strike team server with our Rogue Labs helper script. So we're going to go ahead and run this just like we would on the team server itself. And then it should prompt us for an IP address where it can go execute this command on the team server. So let's go ahead and give it a sudo because you have to run sudo to run your team server. We're going to give it just a random IP address. So let's go in 192.168.1.1. Again, this IP address is not used for anything specific within Cobalt Strike. It's just used to autofill some future menus when we're creating our listeners, but we actually don't need the autofill at all because we're going to use something different altogether. So random IP address, check. We're going to go ahead and enter in the password. Now, big learning opportunity here. This password cannot contain symbols. We're just going to use letters and numbers. Our Rogue Labs helper script will deny anything that has symbols in it for security reasons, but I do want you to think about the real world. When you run this team server command in the real world in a shell, symbols will potentially break that shell as well. So be careful. Whenever you're starting a team server, we'd recommend making the password really long, hard to guess, but try to avoid symbols as those can break your terminal. With these in place, you do need to specify the Cobalt Strike C2 profile you would like to send. We're going to go ahead and give it the jQuery profile. If you'll recall, we ran our C2 lint, we validated it, we made our changes. So now we need to actually send this profile and get it to run on the team server. And then optionally, you can specify a kill date at the end here. I'm not going to bother with that. I'm going to go ahead and execute this. Now, if you haven't, please click over to the curriculum viewer and look at the lab information sheet. That will give you all the credentials you need to work on the Kali attack, the Windows attack, and all the redirector information in there. Now, the password for most of the operator different virtual machines and logins is password, just to make it nice and easy for you. Now our helper script is asking, what IP address do you want to execute this on? We're going to go with the IP address we've been using, which should be 172.30.1.5. Again, this could change in future iterations of the class, so please consult that lab information overview guide for up-to-date information on what your team server IP address is in this situation. So we're going to go ahead and launch that. You'll notice, it does take a second to initialize the team server. It's going to push that C2 profile to the team server. It's going to add that password as the password to log into the team server, and it's going to start synchronizing different logs back to this Cobalt Strike directory. So again, this could take 20 seconds, 30 seconds, 90 seconds at max. If you notice it's taking longer than 90 seconds and it's not starting, feel free to comment in Discord and we'll jump in and help you out. Now, once it loads, you'll notice there is a C2 profile MD5 sum given. And this is so you can very quickly see, all right, this is the C2 profile that's loaded on the team server. If you're making a lot of local changes, this will allow you to verify the correct one is loaded. It also gives you the name of the profile that's loaded, as well as any ports that are active. So once you start setting up your listeners, once you start setting up tunnels, you'll see these ports start to change. As you can see, it just updated, letting me know the team server 550 port is open, which is what we expect. You also have a live server heartbeat here that's telling you, yes, the team server is currently started. If you notice this starts to drift, if it's minutes before it's updating, that may indicate the team server crashed or something else could be afoot. And then lastly, like I said, it's going to sync back all of your implant logs to this logs directory, as well as all the team server logs as the server logs. And we can actually look at that right now. If we go to our desktop in our Cobalt Strike, we can cat out our server logs.txt. This is exactly what the team server is printing out. So you'll very quickly be able to see if there's any errors, listeners that aren't started that should be, that sort of thing. And then one final thing I want to point out here. If you look at the logs directory here, these are the implant logs that'll be synced back to this folder. So later on in class, when we start grepping through the different logs of implants that are calling us back, although we're not running the team server on our local system, the logs are synced back. We can very easily CD and grep through them just like we would in the real world. So number 4, this one is check and done. We're going to open another terminal and we're going to launch the Cobalt Strike GUI. So to launch the Cobalt Strike GUI, I need to open another terminal, which now you should probably start to realize we're going to have a lot of terminals open doing different things. That's why I prefer to have different tabs. As you can see, I have one tab open with that team server. I've got my Keep Alive heartbeat. It's syncing those logs back and forth. And then I'm going to go ahead and we'll CD up to our Cobalt Strike folder here, do an ls, and I'm going to launch my Cobalt Strike GUI straight from here. So we're going to do /Cobalt Strike. That's going to open up kind of the start of our GUI here. And then we need to punch in our IP address information. So I'm going to go ahead and give it the IP to the team server that I've been giving it this whole time. So we're going to do 172.30.1.5. That should connect into that team server virtual machine system. I need to put in the password I set. And then the username, that's just the hacker handle you want to use. This isn't necessarily used for any type of authentication. It's not going to take a username and password. It's just going to log this username next to all the different commands I use. So if you're collaborating with a big team of operators, you'll know who everybody is by their username. So I'm going to go ahead and put in Nick here. We're going to click connect. And then it says, hey, this is your fingerprint. You could cat out that team server log and verify that fingerprint. As you can see, there is a ton of different functionality packed into the GUI. It is really easy to use, which I appreciate. So let's go ahead, let's go straight to those listeners and we'll get our listener set up so we can start creating some beacons. So our lab over here, once the GUI is connected, set up the 2 HTTPS listeners. Remember, we have our primary redirector and then we have our secondary redirector. So we're gonna click our headphones up here. We're gonna click add to create that listener. And then we're gonna name it HTTPS primary. And then I'm actually gonna put right here the domain name that I'm gonna point all my beacons to, just so I can reference which listener is which. So HTTPS primary energysurvey.local. And again, that energysurvey.local information is in that lab overview. The second thing we want to make sure is to set our payload to HTTPS. And then I'm going to continue down this listener, updating all the information to exactly what those slides said. If you recall, I pointed out that specific slide that had the entire listener configuration. So I'm going to continue on here. HTTPS hosts energysurvey.local. Again, this is the redirector I'm setting up, this fake website that all my implant traffic is gonna flow through. So let's get that set up. We're gonna leave this to round robin, max retray none. This is just some extra functionality where you can have beacons iterate through different websites, which can be a good option. We're just not gonna use it in this class. I'm gonna set the HTTPS host to energysurvey.local. So any staging beacons are gonna stage the rest of their shellcode through just the same redirector. Profile, this is the one a lot of students forget. We're gonna set this to primary. HTTPS port C2, 443, perfect. HTTPS port bind, 443, and now I'm good to go. You can also put some guardrails in place if you want to restrict your implants to only execute on specific hosts, but we're going to go ahead and skip that for now. So I'm going to click save. Excellent, everything's set up perfect. Started my listener. I'm going to click add again, and we're going to do all this again, but we're going to use our backup redirector. So I'm going to do HTTPS backup powerpoints.local because that's my backup redirector. Beacon HTTPS, our hosts, powerpoints.local. Our profile we have to set to backup, remember? Now this is where things can get a little tricky. We want the HTTPS port to be 443, but then we want to set the HTTPS port bind to 4443. And that's what's notated in that slide. Because we're already listening on port 443 on our Cobalt Strike team server, we have to listen on an alternate port here. All of our implants are still gonna hit our backup redirector on 443. It's just that last hop that'll be going to the alternate port. So I'm gonna click save, get that created, started listener, success, awesome. And at this point, we have completed step 4. We got our listener set up, and we can move on to copying our arsenal kit. So this step is really easy. Cobalt Strike makes it easy to load in third-party scripts and other add-ons. So let's move over to our resources folder here. We're gonna go to CNAs, BOFs, and our arsenal kit zip. Let's open that up here. And then we wanna copy that somewhere where we know it is. So let's jump to our desktop. I'm gonna put it in Cobalt Strike since it's a Cobalt Strike add-on here. So let's go ahead and drop it in there. And then within Cobalt Strike, we're just gonna go to Cobalt Strike, Script Manager, load right here at the bottom, desktop, Cobalt Strike, Arsenal Kit. We'll go to the dist folder, and then we're gonna load Arsenal Kit CNA. Very easy, very straightforward. Once that's loaded up, we are good to go as long as it appears in here. On to some more knowledge-based questions. Question 4. What is the purpose of Arsenal Kit CNA? Why is it incredibly important operators load the CNA every single time they start Cobalt Strike? Now we mentioned this from lecture, but Arsenal Kit CNA is what's responsible for obfuscating all of those beacon payloads that we're gonna create. If we don't load that, every beacon we create will look like every other beacon out there that is highly signatured in customer networks. We also mentioned a lot of red team organizations likely have their very own Arsenal Kit that you need to load when you start working for their team to make your beacons look like how they want. Question 5, why is it a bad idea to execute the Cobalt Strike team server or GUI in the background with the ampersand argument? Well, we mentioned in lecture, if you background either the Cobalt Strike team server or the GUI, all those status messages that it's going to be responding with and kicking out to the screen will just clutter up your terminal. It'll be hard to locate it if you have any errors. It's best just to run that in the foreground and then run multiple different terminal tabs. If you end up inviting a friend to operate in Rogue Arena, should you both start Cobalt Strike team servers? The answer here is just kind of get your mind thinking through. Cobalt Strike is a collaborative platform. You could have 6 different operators connected to the same team server, all issuing commands to different implants, operating alongside each other. You only really need one team server instance for you all to connect to. Which brings us to our Apache ProxyPass configuration update. The slides do detail how to connect up, how to run Nano. I'm gonna go ahead and demonstrate some of that for us right now. So we're gonna open another terminal. We're gonna get zoomed in here. Again, if you read that lab overview document, it has all the IP addresses and all the credential information that you need to continue with this assessment. But lucky for me, I have it all memorized. Yay. So we're gonna SSH, we're gonna go rogue operator at 172.100.110. This is our redirector we're SSHing up to. The password is password. You should all know that after reading that overview document. And now we're officially on the redirector. Now we're gonna going to want to update that redirector config file to point at our Cobalt Strike team server. Remember, all the traffic is going to be exiting our customer network, hitting our website redirector, and then our redirector is either going to serve up website content to users or forward our implant traffic back to that Cobalt Strike team server. So what we want to do is we're going to do a sudo nano etc Apache 2 sites available and default ssl.conf. We're going to put in our password, which should be password. Then we're going to scroll on down to our URI here. Now we've put a lot of placeholders in place to make this fairly simple. So we want to replace our root URI with energy forms. As you'll recall, you found this root URI back when you were going through that C2 profile. You identified our primary redirector had energy forms, and then that secondary redirector had power forms. So I'm going to do energy forms here. We're going to go up, find our IP address here. And this needs to be our team server IP address. So again, same IP address we've been putting in everywhere else. Our port is going to be 443. And then our root URI, we're going to put as energy forms. So we'll do energy forms. Then we're just going to Control X, Y, enter. That will save the file. If you are a VI person, have fun. VI is on the redirector. I can never remember those hotkeys, so nano it is for me. So we're going to do sudo service Apache 2 restart. And if everything works, you should be good to go. You shouldn't have any errors or other messages here. Our next step is going to be update this exact same configuration, but on our backup redirector. So I'm going to go bounce back up to that backup redirector. Again, we're going to do sudo nano etc Apache 2 sites available, default SSL conf, put in our password here. And then we're going to scroll down, and this one's a little bit different. So we're going to go over to our rewrite role. We're going to update the root URI here to be our power forms, because this is our backup. So power forms. It may say Kali IP address here. This is an older lab instance. So I'm going to go ahead and put the team server IP address here, just like we keep talking about. And then finally, our port is going to be 4443. Because if you'll recall, 443 is already in use on our Cobalt Strike team server. So we have to set that back up to call to 4443. Now, don't be afraid. All of your implant traffic leaving the customer network is still flowing out to the internet over HTTPS port 443. This 4443 is just happening kind of in a back channel from your redirector to your team server. So I'm going to go replace this second URI here with power forms. Final step, we're going to do our sudo service Apache 2 restart. And we're definitely not going to make typos like that. So sudo service Apache 2 restart, no messages here. So I should be good to go and we should be ready to proceed. So jumping over to our lab guide, because again, our lab will kind of keep us directed through all of this. It says, go ahead and test the redirector configuration on both redirectors. Open Firefox on your Kali attack, and then surf to the following redirectors. And it even gives us a little result that we should see. So let me load up Firefox here. And we want to browse to https energysurvey.local. So https energysurvey.local. It pops up an SSL cert, that's okay. We're just using some self-signed certs in the lab here. And it loads our website. So this is our energysurvey.local website. You can read through it if you want. But, you know, that was a successful test. It says this page should load all web content normally. Now, if we browse to our base URI and then test primary, let's see what we get. So /energy forms /test primary. Now we get a blank page. And that's because it's forwarding it to our Cobalt Strike team server. And we can validate that by pulling up Cobalt Strike, go to View, Weblog, and we can see the exact hit to our team server. So let's test the same thing on our backup redirector. So that is https powerpoints.local. Again, you know, SSL cert, we'll accept that, accept the risk and continue. Loads our template website, so exciting. /powerforms test backup, blank page, that's a really good sign. Cobalt Strike, validated the Git. If you didn't set up your Apache ProxyPass successfully, you would likely get some weird Apache error there saying, I don't know what you're trying to do. Or if your team server was down, it probably would time out. You wouldn't get that blank page load. But if you get that blank page and you come over here and you see these two gets right here, you're good to go. Awesome, so we tested that. That brings us to our two next knowledge-based questions. Number 7, if Electro JNN defenders see implant traffic leaving their network, will they see it communicating with your Kali attack machine? The answer is no. That's the whole purpose of our red team redirectors. Defenders will not see that traffic hit your Kali machine or even your Cobalt Strike team server. Remember, all that traffic is hitting our redirector first. So that's where all the defenders would see it, hitting that redirector, and then on the back end, kind of where they can't see it, flows down and hits your team server. So if defenders do see traffic leaving that victim machine, all they'll think is the user is browsing the internet. Number 8 here, if Electro JNN blocks access to your primary redirector, what options do you have to reestablish access? Now in the perfect world, and we're actually going to be doing this in future labs, hopefully you have primary implants calling out to your primary redirector, but let's say, you own the whole domain. Let's say you're on 6 different victim computers, maybe implant 2 of those with your backup implants. That means if they block all of your access going through your primary redirector, our secondary redirector, which is our powerpoints.local, will still be active. So we could easily pivot to those beacons and continue our assessment or continue to establish more access. Moving on down, final configuration and testing. Copy the mission share to your Kali Attack desktop to stay organized. And this one's easy. So we're gonna go to Cobalt Strike, go to our resources folder over here, and then we have this mission share template. Let's drop that on our desktop. And we just have a lot of different common folders that should allow you to stay organized. So we have OSINT, Recon, credentials, all sorts of exciting things in here. Now comes the really, really important part with a small detail here. We want to create and test all 4 variations of our beacon payloads. This will ensure all of our infrastructure is set up correctly. We can launch our campaign against Electro JNN without any fear of stuff being misconfigured from this point. So to do that, we're going to create 4 beacon payloads. We're going to go to Payloads, Windows Stager, and then we're going to create a primary. We're going to leave the rest default. So let's generate that. And then I'll throw it in that mission share under Payloads. Let's create a new folder here and we'll call it Implants. Or we'll call it Test Implants. How about that? And then this is our artifact. So this is a stager primary.exe. We'll create another stager. Let's go ahead and pick our backup redirector here. Generate. So this is our stager backup. Awesome. Now we're going to do that same thing, but we want to pick our stageless payload. And remember, those stager payloads, those are the smaller file size. When they run, they call out, pull down the bigger implant to then run in memory. A stageless payload, which is what we're about to create, that is the larger file size. That's everything the implant needs to run. So it's cryptographically keyed to my team server. File size is a little bit bigger. It's good to go. So we're going to go stageless primary. We'll just leave everything default, click generate. And then I'm just going to kind of steal the name over here and we'll call it stageless primary. And then we can go to payloads, stageless, set up our backup, generate. And this will be our backup redirector. Now, another little tidbit for you all, if you go to Cobalt Strike script console, you'll actually see everything going on here as the Arsenal kit is obfuscating all of our payloads. It's pretty cool how you can see all these little details to ensure all these little things are working correctly. The last step is to copy these over to our Windows attack machine and just run them all. It's that easy, right? So I'm gonna go ahead, let's minimize our Cobalt Strike. I'm just gonna grab these payloads real quick, test implants. I'm just gonna copy the whole folder. Desktop, here's our student share folder. This should be linked over and also be on the Windows attack. I'm gonna paste them right here, test implants, minimize our Kali. We'll bring up our Windows attack machine here. I already had it open, but we'll go to our File Explorer, PC, student share. Here's that test implants folder. I'm gonna go ahead and copy them all to my desktop first. So now that our beacons are all here, we're gonna go ahead and double click them one by one, see if we can get them to execute. Hopefully we get the callbacks, right? This is the suspense. 3 callbacks came in. We have 2 stageless and our stager. I'm wondering if maybe I didn't execute the one. Always a good idea to double check. Looks like we're missing our stager primary. So let me minimize this, jump back. Stager primary, that was the last one I clicked. So maybe I misclicked that one. We're good. All right, so we got our 4 callbacks. That means all of our C2 infrastructure was set up properly. Our Apache ProxyPass set up properly. Now that we've confirmed this is all working successfully, we can progress through the lab. Now this is so important and so key, not only in the real world when you're about to execute an operation against a real entity, but also in this class when it comes to troubleshooting. Now that you know all your redirectors are set up, if something fails, at least you know your beacons should have worked. And that'll come into play a little bit more when we jump in with our initial access payload. All right, now it says feel free to click around Cobalt Strike and explore some different functions, you know, uploading files, downloading files, all sorts of cool stuff. So as you wrap up this lab, make sure you interact with at least one beacon. So we'll actually click over, you know, you can pick any of these that just came in. You have some of the IP information about the beacon, the listener that's configured for that beacon, the user that's calling you back. This can be really important. When you get your first initial access callback from the victim environment, it's very important to look at the user column here. It'll give you your Windows host name, which is Windows attack in my case. You can set a custom note, which we'll talk about in a little bit. But I'm gonna go ahead, right click, interact. Let's try running a sleep 2 because we really want to sleep this down so it's very fast. Again, in class, use your sleep with like the number 2 that's going to sleep at the 2 seconds between intervals. That'll allow you to keep training and keep operating very quickly. In the real world, you'll want to sleep to like 45 seconds to even 60 seconds, even to 2 minutes. It all kind of depends on the target environment you're in and how well it's set up. So while we wait for this come back, it says run help to get a list of all beacon plugins. So I'm going to do that. I'm going to run help. These are all the plugins I have available. So again, feel free to explore, run some of these, kind of poke around, see what's there. If you need more information about a plugin, you can do help and then the plugin name. So they'll give you the syntax of how to run, you know, the download command or help PS. This one's very easy. It just says use PS. So I'm gonna go ahead and run PS. This will do a Cobalt Strike process list on this machine. It's gonna go out there, pull down all the processes that are currently running on the machine, and I can page through it, see what's up here. It looks like they have OneDrive open or at least running in the background. I can see my other Cobalt Strike beacons. Obviously, this is my Windows attack machine, but the goal here is just to get comfortable running some of these different plugins. Now let's answer these knowledge-based questions real quick before we close out this video. Why could it be helpful to allow these 2 test implants to continue running while we execute our operation? And typically that is to just keep a running implant so we can test that redirector and that Apache ProxyPass. If you lose connectivity to all your victims in the target environment and your Windows attack stop calling you back, that could be a problem with your redirector, right? But if all those victim machines, you lose contact with all those beacons, but your test ones here keep calling back, that's a bad sign. That could mean that you just got blocked. Question 10, if you're ever stuck trying to remember syntax for a beacon command, what can you run to list syntax and helpful commands? I'm gonna hammer on this so much, even to all of you in the self-led, I'm gonna constantly point out, you need to run the help command to list out all those available plugins, and then run help, the plugin name, to get syntax. Typically when I'm teaching this class in person, I have students all the time, hey, what was the syntax for, you know, that service command? I always respond and say, hey, run help, then your service name. That's gonna do you so much more to learn how to use your help syntax and kind of mold your commands from there. You'll be able to reuse that in actual operations and be way more successful. And then lastly here, your first stretch lab. I'm not gonna talk too much about this one, but if you're up for a challenge, definitely knock out those stretch labs. They're definitely a lot of fun and will teach you some new stuff. So that's the end of this video. I hope you enjoyed your first lab. Again, this one's a little different. We went through all this up front and now it's up to you to log into Rogue Arena and run through all of this on your own. I just showed you step by step how to set up infrastructure, how to set up your Apache ProxyPass. Good luck, jump in there, knock it out, and then click over to the next video and we'll keep running with stuff.